living as a teenager, you hear out of the corner of your ear phrases like, let's take a 0.5. And maybe, if you're lucky, your really cool rich friends with the newest iPhone might ask you to be in their 0.5 for Be Real. And other times, someone will text you a really distorted picture of you supposedly taken on a 0.5. No, you cannot get the unblurred version. But if you're like me, the first thing that comes to your mind is, what actually is a 0.5? Just looking at the image they produce, it's clearly a very wide angle. I originally thought that 0.5 must have meant 0.5 millimeter lens, and this could make sense theoretically if the sensor was small enough to cause a crop factor that would make the 0.5 millimeter lens actually look like something that could be usable. However, I greatly overestimated an iPhone sensor's ability to be tiny. To explain what's going on here, we're gonna need some math. But first, before we start, sources will be in the description, and if you like this video, please like, share, subscribe, or do anything else that may help the channel. I put a lot of love into these videos. Additionally, I'm not an expert, I just like research and think optics are cool, so if I get anything wrong, let me know in the comments. Now let's learn some facts, terms, and formulas. Your iPhone with the 0.5 mode contains a far smaller imaging sensor than other cameras, such as DSLRs or DSLMs, due to the nature and how tiny iPhones are. For reference, here is the CMOS sensor on my Panasonic GH5, which is a micro four thirds sensor DSLM. This sensor is about 2.5 times larger than a typical phone camera sensor, and micro four thirds in general is a lot smaller than other professional camera sensors. And very small camera sensors can produce beautiful images, as I'm sure you know. But the size of the sensor impacts tons of other variables, such as heat dispersion, effective focal length, software, power consumption, field of view, depth of field, and tons more. We'll just focus on the visual impacts, though. First, what is focal length? Well, technically, it's the distance between the optical center of a lens or lens group and its focus point, which is normally the imaging medium. Practically, it's how zoomed in or out your image will appear. Focal length also affects distortion, like barrel distortion on fisheye lenses. There's also pincushion distortion that can happen at longer or higher focal lengths. Basically, focal length is the optical zoom. Field of view is how much the lens can see, often expressed as diagonal degrees. This is impacted by the sensor size, focal length, and the sensor's aspect ratio. You most likely know what field of view means in practice from video games. Here is Halo Infinite. As the field of view increases, we see more on the edges of our screen, and the center seems to get further away. So for instance, my Lumix 12 to 35mm, it zooms in like that, and as you zoom in, the field of view decreases. For reference, a working and standard set of human eyes has a field of view of about 180 degrees, although it's not all used because, faces get in the way. The formula for field of view is 2 tangent -1 times the diagonal of the imaging medium divided by 2 times the focal length. Depth of field is the distance between the close and far points of an image which are considered to be acceptably sharp, which is a loaded term. A link to a video which explains the insanely complex world of depth of field will be in the description, because I do not want to spend the time to research it fully. Essentially, a lower f-stop number will increase the amount of blur you see. Sensor size, which will impact the crop factor, will also make your out of focus area appear different across formats. We should know two more terms before we do the math. The diagonal of an imaging medium is the distance from a corner to the opposite corner, which you can then use the Pythagorean theorem from geometry class to calculate. The other term we need is the crop factor. Lenses are marked in relativity to 35mm film. But since sensor sizes are not the same lens will look completely different across sensor sizes. For example, that is a 35 to 100mm lens, but on Micro Four Thirds, which I am shooting on, it is equivalent to 70 to 200. The formula for crop factor is the diagonal of 35mm film divided by the diagonal of whatever sensor you're using. This is what we will be using to determine the true nature of 0.5 mode on the iPhone. Now that we have a basic understanding of how sensor size impacts the image you get, let's do some math and figure out these formulas. First, let's find the crop factors. We'll do calculations for medium format, 35mm full frame, Micro Four Thirds, and iPhone 13 Pro Max wide, as well as iPhone 13 Ultra wide, which is the same as the telephoto sensor. The first step to finding crop factor is getting the diagonal dimensions of the sensors. Since we need the diagonal of a full frame sensor for math later on, I'll do this one together. The length of a full frame sensor is 36mm, and the width is 24mm. So we take those values and square them, and then add them together, and that will get our diagonal squared. Then we do the math. 36 squared is 1296 plus 24 squared equals 576 equals d second. And then we add up those numbers, and that gets us 1872. And that's still d squared. So then we have to square root those sides, so we just have 1d. So we'll take 1872, square root that, and that gives us 43.267. We'll go 3 decimal spaces there. Here are all the dimensions for every sensor type. Where's my pen? I lost my pen. I'll have to point with my finger, which is kind of lame. So full frame is 43.2, Micro Four Thirds is 21.64, medium format is 55, the iPhone 13 Max wide is about 9.69, and the iPhone Max Ultra wide and Tele is about 5.286. Next, we take this diagonal number and plug it into our crop factor formula. Let's do medium format for this one. So 43.27 divided by 55 gives us a crop factor of 0.786, which is obviously less than 1. Values less than 1 will make a lens look wider than it truly is, and lenses greater than 1 will make a lens look tighter than it actually is. Let's get the crop factors for every other sensor. Alright, so 35mm has, you guessed it, a 1 crop factor. Micro Four Thirds has a 1.9995, or a 2 crop factor. Medium format has a 0.786. iPhone 13 Max wide has a 4.465. And iPhone Max Ultra wide and Tele has an 8.1857. To find the field of view, we need another formula. 2 arctan is written as tan -1, as you see right here on a calculator, times x, the diagonal of an imaging medium, divided by 2 times the focal length. That will get us the field of view. For this equation, we need a focal length constant, so let's choose 50mm. And that gets us 46.796 degrees of diagonal field of view. Medium format will have more degrees in view than full frame with a 50mm lens, and each crop sensor will have less. So how do we figure out what an iPhone camera actually is? Apple provides us the 35mm equivalents for each of their 3 lenses. The iPhone 13 Max wide is 26 equivalent, the ultra wide is 13, and the telephoto is 77. Now we can use those wondrous formulas to calculate what the real focal length of the actual glass is. So let's start with wide. The equation we're looking for is for the true focal length, which we can derive from our 35mm equivalent equation, which was true focal length f times crop factor c equals the 35mm equivalent. So we can just divide this side by c and this side by c to get our true focal length. And now we have this equation. So if we plug in our numbers, we get f equals 26, which was the 35mm equivalent, divided by c, which is 4.465. If you do that math, you get that our true focal length equals 5.823. So if you take a look at our chart here, you'll find that we see that the true focal length of each camera is actually really tiny and wide, but the crop factor makes it so it looks usual. But don't think I've forgotten about iPhone's field of view. Let's use a formula to see the field of view of an iPhone lens on a full frame camera. We're going to use the wide or the 26mm equivalent lens for this demonstration. The wide lens has a true focal length of 5.823 millimeters. If we do calculations for a field of view of the 5.823mm lens on the iPhone sensor, we get a field of view of 79.52 degrees, which is about the same field of view of a true 26mm lens on a full frame camera, and that makes sense. However, when we take the iPhone wide 5.823mm lens and stick it right on a full frame camera, our field of view is dramatically increased, going up to 179.83 degrees. That's because the crop factor of our sensor is no longer increasing our focal length by 4.5 times. A crop is just taking the middle of the lens and blowing it up to fill the entire frame. So you lose all that field of view that gets cut off. Remember, as focal length increases, the field of view decreases given the same sensor size. So let's summarize what we've learned. Apple's popular 0.5 mode is actually a 1.588135mm lens, which we reverse engineered using the stated 35mm equivalent focal length and crop factor. The lens is fixed on a 5.268mm diagonal sensor, which after dividing the full frame sensor by the tiny sensor, produces a 4.465 crop factor. This outputs an image that shares the field of view of a 13mm lens on a full frame camera. So that doesn't actually answer the question. So why did 0.5 mode get its name? The funny thing is, it's a very simple answer that did not require any of this math. I actually realized this when I was writing the script. I overcomplicated it as usual. Apple calls the wide mode the 26mm lens, and the ultra wide mode is 13mm. And you may have noticed 26 is twice as big as 13, and therefore 13 is half of 26. And what's another way to write half? 0.5. But the lenses themselves don't actually have this relationship. The true focal lengths are 5.823 and 1.588, actually putting them 3.7 times apart. So 0.5 only appears to be twice as small as the main camera because of the sensor size. It's not actually the lens. I sincerely hope you enjoyed this video and learned something while you were at it. I also hope my math teachers enjoy viewing the product of this incredible teaching they've done over the years. Notice how I said product. That's a little math joke. If I did get something wrong, please let me know in the comments, and if you did enjoy, consider liking, subscribing, commenting, sharing, the usual, or doing anything else that you think may help out the channel, because that is always highly appreciated. Thank you so much for watching. You may or may not see me next time, and as always, you can stick around after the outro to see the photo of the week. CWG does not pertain to anything other than my channel name in this context. CWG does not relate to any of the acronym and should not be inferred as relating to